Right, we're going to do some solving equations and inequalities with the modulus function, and you really need to use a graphical method for these. The ones with numbers on the right hand side you could kind of get away without the graphical method, but I'll introduce it straight away. So the first thing you need to think about is looking at where the modulus of x plus 2 equals 4. And to be fair, you could just let x plus 2 equal 4 or x plus 2 equal minus 4. But using a more of a graphical method, we're looking at where does y equal the modulus of x plus 2 intersect with y equals 4. So graph of modulus of x plus 2, this is y equals modulus of x that's been moved left by 2 if you think about your transformations, or when y is 0, modulus of x plus 2 is 0, and so x has to equal minus 2. When x is 0, y is 2, and so my y-axis intercept is at 2. Gradient's 1, so you should know it's at 2 anyway. So it's coming up like so. Equations of line segments. So this bit here is y equals x plus 2. This bit is y equals minus x plus 2. And if I also draw on the line y equals 4, so to find where they meet, you would solve their equations simultaneously, and that would take you to there. But because the equation of the line segments are different, we need to think, okay, x plus 2, so this point of intersection here is where x plus 2 equals 4, and so x equals 2. This one here is where minus x plus 2 is 4. So x plus 2 is equal to minus 4, and x is equal to minus 6. So if I put them onto my graph, that's at minus 6, and that one there is at 2. So these are the answers to modulus of x plus 2 equals 4. So if you were solving that as an equation, to find where the modulus of x plus 2 is less than 4, you're looking at where is the graph of the modulus below 4, because we're looking at the y values here, and the y values are less than 4 all the way along here and all the way to here. So it's like doing the inequalities we did with the quadratics. And so modulus of x plus 2 less than 4 means that you're sandwiched between minus 6 and 2. So that's where the value of the modulus is less than 4. Remember, that's the value of the function is your y value. Similarly to the inequalities we've seen before, if you want to find where the modulus of x plus 2 is, let's say, greater than or equal to 4, then it'd be along here and along here. So you'd write that as x less than or equal to minus 6, or x greater than or equal to 2. So you have to do 2 separate inequalities for that one. Doing one that's just a little bit more involved. So we'll look at, keep an eye on the time, I think I'm okay. If we look at modulus of x plus 2 is equal to 2x plus 7. So sketching this, I've just done modulus of x plus 2, so I can just whack that on. Actually, let me make that scale slightly better. So we go minus 2, 2. Oh, sorry, it's all going to pot. I'm under time pressure. Right, so that's the graph of y equals modulus of x plus 2. And then I'm looking at where does, same as before, y equals modulus of x plus 2 intersect with y equals 2x plus 7. And then you solve those simultaneously, which takes you to there. So sketching y equals 2x plus 7, when x is 0, y is 7. So I'm going to be up here somewhere. And when y is 0, x is minus 7 over 2, which will be here somewhere. And then I can draw on the graph, like so. This graph has a gradient of 1. This graph has a gradient of 2. So this one is steeper than this one. So it's not going to intersect this modulus function on the right hand side. And that's the bit that you need to get really clear, is where are your points of intersection. Then you need to also think about your line segments. So this is y equals x plus 2. This bit here is y equals minus x plus 2. So to find this point of intersection of the line and the modulus function, you need to do minus x plus 2 equals, and then the equation of this line, which is 2x plus 7. Solving that, I've got minus x minus 2 equals 2x plus 7. 3x is minus 9, and so x is equal to minus 3. And then you could also talk about where's the value of this bigger than the modulus, where is the value smaller than the modulus. So if you wanted to do modulus of x plus 2 is less than 2x plus 7, then we're below, the modulus is below this graph for all values of x bigger than minus 3. But you're only going to get all this information from a graph, so you need to find the equations of the line segments for your relative points of intersection. If you were solving, for instance, modulus of x plus 2 equals minus a half x, and I draw on a graph minus a half x, that's going to have a shallower gradient than this one. So it would come across, I don't know, something like that. Then you will get 2 points of intersection. And so in this case, you would do minus x plus 2 equals minus a half x. And you would also consider x plus 2 equals minus a half x. And then solving those, you'll end up with 2 values of x for where x plus 2 equals minus a half x. Yeah, I think I've got time to actually do that for you. So you need to draw a graph And you need to think about the steepness of the graph. Will it intersect this one again? If it's shallow enough, it will. And you'll have 2 points of intersection. So if you've got a gradient less than 1 coming across here, you'll get 2 points. Gradient bigger than 1 coming across here, you're just going to pick up this 1 point of intersection.